in v bistvu, ki je partner v projektu Inspire, ki vodimo v bistvu delovni sklop povezan s trajnostjo in tudi vodimo demonstracijsko središče tukaj v državah. Ja, še enkrat bi se rad zahvalila Majetki in vsem vam, ki ste pripomogli k temu dogodku. Zdaj, kaj je Inspire? Inspire projekt je približno nekje na polovici, sestavljen iz 26 partnerjev iz 15 različnih držav z skupnim mindsetom, da najdemo inovativne solucije, ki jih testiramo v pravih okoljih, ter tudi potem izmerimo podatke oziroma rezultate senzorično in tudi z drugimi metodami. Ideja je, se pravi, da se naredijo replikacije na večjem skelu. Trenutno je to pilotni projekt, ki se ukvarjamo z enim kubikom vode na dan, jo počistimo. Kot pa vemo, imamo letko malo večje kapacitete kot en kubik na dan in seveda dolgoročni plan je, da bi se tehnologije, ki so ki se najdejo primerne za takšne aplikacije, potem tudi skelale na večji nivo in jih tudi potem implementirali na večji skali. So yes, again, Inspire project is a big European mission project under the Restore Oceans and Waters, which is basically comprised of 26 partners from 15 different countries. And our common goal and mindset is to find innovative solutions, try them out, measure results, and of course with data-driven KPIs, optimize, replicate, and scale the technologies developed and proposed under this proposal. So, as I said, Inspire is a 4-year-old mission project funded under the Horizon Mission Ocean, and it will contribute to the drastic reduction of litter. Here I'm tackling macro and micro litter. Where here on this specific demo site in Slovenia, we are mostly focusing on the microplastic and nanoplastic litter in the effluent of the wastewater treatment plant. So the main goal is to support the mission, Restore Ocean and Waters, by reducing at least 50% macroplastic litter in the European oceans and waters, and also to reduce 30% of microplastics in the European waters. Še v slovenščini mogoče Inspire 4-letni projekt pod misijo Oceani, ki je v bistvu se zavzemamo za drastično redukcijo mikro in makroplastičnega onesnaženja v evropskih rekah. Ključni cilji Evropske komisije so, da zmanjšamo vsaj 50% makroplastičnih odpadkov v evropskih rekah do leta 2030 ter 30% mikroplastičnih odpadkov v evropskih rekah. So, the working methodology of Inspire is drafted here. It's a pretty complex thing, so I will not go into the details. We call it a holistic DCP approach. Basically, D stands for detection, collection, and then, of course, prevention measures for stopping micro and microplastics in our waters. So, še v slovenščini, to je metodologija, v katere se osredotočamo na podprojektom Inspire, ki so v bistvu razviti trije koncepti, ki se potem na koncu združijo v bistvu v en akcijski plan, s katerim bi želeli v bistvu Evropski komisiji predlagati rešitve za doseganje njihovih ciljev. So, these are as I mentioned, there are 26 partners in this project, and we have 6 demo sites around Europe and also a couple of use cases, but I will not talk about them today. So for the demo sites, we are here today in our beautiful Slovenia, so thank you all for coming, where we will test some solutions and also will try to show them to you so you can have the real experience of the microplastic cleaning from our waters. Tole je v bistvu struktura Inspire demonstracijskih središč. Danes se nahajamo seveda v Sloveniji, kot vsi vemo, še hvala, da ste prišli. In pokazali bomo, kaj smo delali v zadnjih 2 leti. Sicer tukaj se osredotočimo na odstranitev mikroplastike iz vodnih medijev. Na drugih demosajtih pa seveda delajo, se ukvarjajo z drugimi problematikami. Moram še povedati, da za mikroplastiko se ukvarjajo na 3 demonstracijskih središčih, eno v Sloveniji, eno v Portugalskem in tretjo v Romuniji, kjer se ukvarjajo z različnimi aspekti mikroplastičnih polucij na že prej identificiranih vročih točkah. Tukaj je še par slik iz naših demotov, da se delamo tudi drugje kaj, ampak več bodo pa povedali kolegi. So yeah, one more thing in English maybe. These are the locations of inspired demo sites. We are tackling microplastic pollutions in 3 demo sites, specifically one in Slovenia, one in Porto, and the third one in Romania. Where in Slovenia we are tackling the effluent of the wastewater treatment streams. Then in Porto they are tackling the pollution from the wastewaters in Marina. And in Romania, they are very advanced and they are tackling the problem of the tire wear in the highway waters. That would be it. Here are some pictures from different demos, so you see that we have many different activities. And this is something that I'm finalizing because my dear colleagues will explain more into the details. So I would kindly ask Marietta if you can take the stage. Thank you very much.
Lep pozdrav tudi v mojem imenu. Moje ime je Marietta Kralevska, ki sem direktorica čistile naprave Državni Kamnik. Warm welcome to everybody at our treatment plant. I'm the CEO of this plant. My name is Marietta Kralevska. Zakaj je čistila naprava Državni Kamnik? Ana Marija je pomenila reko Kamniška Bistrica. Kamniška Bistrica je zelo občutljiv rečni sistem, hudourniška reka, kar pomeni, da njen pretok se spreminja iz minute v minuto. In iz tega razloga, ker mi kot čistilna naprava vračamo reki prečiščeno vodo, da seveda tudi zanima, ali lahko to prečiščeno vodo še bolje očistimo. In mikroplastika je sigurno ena izmed teh snovi. Pred 10 leti smo naročili prvo analizo mikroplastike v Inštitutu za vode in presenečeno ugotovili, da v našem iztoku, kljub temu, da je videti bister, pa ne konkretno imate današnji iztok, v primerjavi z vodovodno vodo, smo ugotovili, da pravzaprav v čiščeni vodi se še vedno nahajajo delci. Po tretji stopnji čiščenja leta 2017, seveda ta učinek čiščenja dvignil iz 20 na 96% posredovanja mikroplastike. Vendar v iztoku se še vedno nahaja recimo okoli 7 delcev, ki so seveda organizmi poškodbe. 7 delcev na liter. Pri dnevni količini 20.000 kubičnih metrov na dan čiščene vode, to pomeni 124 milijonov delcev, emitiramo vsak dan v vodotok Kamniške Bistrice. To so velike številke. Če bomo šli še z dnevi in z leti, vidimo, da se ta mikroplastika nalaga v vodotokih, razpada v nanoplastiko in počasi prehaja v vodni krog in seveda tudi kamni krog. In ravno z tega razloga čistilna naprava že nekaj desetletij sodeluje z različnimi raziskovalnimi projekti, tako da smo veseli, da nas je Inspire projekt poiskal. In seveda na tem demo sajtu, v demonstracijskem centru, bomo želeli ugotoviti, na kakšen način, s kakšnimi tehnologijami po naslednjih desetletjih nadgradimo. Tako da, hvala še nekaj. So maybe in English I will try to translate everything I told you in Slovenian language. So first of all, the river Kamniška Bistrica is very sensitive river. It changes the flow day by day because it's coming from the mountains. That means that it's very sensitive. Of course, the effluent is coming into the river Kamniška Bistrica and we are trying to do our best. Over there is our today's effluent. You see, the left side is the effluent, the right side is the effluent. And when we found out 10 years ago, when we ordered the first analysis of microplastics, that we still have microplastic inside, although it looks clear, right? So after the upgrading in 2017, the elimination of microplastics rose from 20 to 96%. And now we have approximately 7 particles per liter of microplastic in our effluent. And if you calculate daily flow, 20,000 cubic meters per day is the effluent flow with the particles, we are calculating that 124 million particles per day is needed for the direct function. And if we count these days, layers, we know how much microplastic is then loaded. And of course, we know that this is degraded to nanoplastic, and then it is entered into underwater and so on. So, yes, why here? We are actually helping research centers for many decades now, and thanks to Inspire that they chose us. We are glad to be here, that we are giving our effort, and that we would like to upgrade our treatment plant in the next 10, 20 years to the 4th stage, and this 4th stage will also be next microplastic. So I wish you a very nice event. Please ask, be curious, and all the best. So, hvala. En izmed naših lastnikov, župana občine Mengeš, Bogor Potar, imamo še ena župana in 3 županov, kot gospod Bogor Potar, prosim, vidite. I would like to introduce our mayor, one of the 6 mayors, municipality Mengeš, Bogor Potar. He will tell us how this will be probably. Yeah, we will translate. Yeah, we will translate.
Najprej lep pozdrav v mojem imenu, v imenu občine Mengeš in seveda lep pozdrav tudi v imenu solastnic ostalih občin, ki smo solastnice te čistilne, naše čistilne, bom rekel, naprave, če smem tako reči. Izjemno smo veseli, da se bo ta projekt odvijal na našem čistilnem področju, ki zajema kar velik del občin. Moram povedati, da vse te občine, katere so solastnice, smo praktično, bom rekel, 99-95% že opremljene z kanalizacijskim sistemom, ki pa vse bazira na to čistilno napravo. Lahko rečem, da smo izjemno zadovoljni z rezultati. Zelo lepo posluje ta čistilna naprava in ima zelo visoko kvaliteto, bom rekel, izpustnih voda. Tako da o zavedanju tega projekta se zavedamo verjetno vsi, kaj to pomeni, bom rekel, ta mikroplastika v svetu, in smo še enkrat poudarili veseli, da bo ta projekt tekel v naši, bom rekel, čistilni napravi in se veselimo seveda tudi rezultatov. Hvala lepa vam za ta projekt, za to odločitev. Verjamem pa, da bo v sodelovanju z vodstvom čistilne naprave oziroma z vsemi tistimi akterji, deležniki, ki so vpleteni v ta projekt, rezultat zelo dober. Hvala lepa in lep dan vsem skupaj še naprej.
Thank you. So I will try to translate. So, Mr. Mayor, he is very glad that we have the demo site here in the Domžale County Treatment Plant. The owners are always supporting us. 95% of the wastewater is already connected to our wastewater treatment plant. They trust us, they know that we do the best, that we have high efficiency of third stage, and that they will support us also in the future. And he is wishing you.
Okay, thank you very much for this introduction to the mayor. Now we would like to basically proceed to our first section, and I would like to ask my lady friend George and the Felix to come up and moderate with us. From now on, the event will go on into the English, because otherwise we will sit here till tomorrow. There's so much to say. And then, yes, George, please, the floor is yours.
Thank you very much. Good morning and welcome. Thank you very much for hosting us in this impressive facility. And it's my first time personally in Slovenia, and I'm really impressed, I have to say, from the country. So thank you very much. Thank you very much for hosting our project here. It is an honor for us to welcome you here. And the first session will be about the Gonzale use case. So we will present to you the technologies that we are applying here. In Inspire project, as Anna Maria explained, we have very many technologies, more than 20. Here you will see 4 of them. And it is a pleasure for me to introduce, apart from Anna Maria, that is the use case leader, and she's a task leader and a work package leader. So a very prominent role for Slovenia in Inspire project. She will explain us briefly the, as we call it, cascade solution. And then it is a pleasure for me to have Mr. Nikos Katsafados from Waste and Water, Mr. George Deligianakis from Delve, Kostya and Arpad Talasi from Clarawan, and Professor Joy Dada from KTH. I have reserved the seat for you here, sir. Sorry.
A bit late, huh?
Thank you. So, Anna Maria now will explain to you about the cascade solution. And then after her presentation, each technology will present briefly what exactly we do. And then we will go to the actual room, and you can see some of these devices that are hosted here. Not all of them arrived yet, but you will see what we are trying to achieve. As of next week, everything will be fully organized and functional, and we will be able to perform our first tests. Thank you very much. Welcome again. I'm George Triantafilidis. I'm the Work Package 2 leader. And if you have some questions, we can a few of them, but you will have the chance to discuss with the technology providers in more detail in the room. Please, Anna Maria, the floor is yours.
So thank you, George, for this kind introduction. As George mentioned, I will briefly just explain to you what we are trying to achieve here in Slovenica on the Kamniška Bistrica river. So, wastewater treatment plants, as you all probably know by now, are identified as one of the hotspots for microplastic discharge into the European rivers and waters. So here we are trying to test the removal and then also the total elimination of microplastics in the water bodies, which I think is the biggest breakthrough in this project, thanks to KTH and Professor Joy. So we're very looking forward to show you the results in the next phase. And I would also like to thank Vito and Liz for their support regarding validation and using advanced analytical methods to help us get below 40 microns to see what we are doing. Hopefully we will see something. I would also like to thank the digital parameter monitoring partner Marco and his team from Infodata for your support with digitalizing this system that we envisioned. And then also together with the University of Cardiff and CIMA, we are performing the monitoring of microplastics in the river Kamniška Bistrica before and after the wastewater treatment plants to evaluate the effect itself on the environment. So for this, I would like to thank my team, especially Jan and Tine, who are doing this great field work. Okay, so this is something similar that you will see hopefully in the room later. So we were very busy last months, I would say. But just in order for you to understand the levels of the removal under this cascade solution, we have, of course, many cascade solutions, but we have to start somewhere. So first, we will definitely do the primary filtration of the effluent thanks to Archivicos from waste and water, Greece, with their Ecoplex device, which will remove particles above 30 micrometers from the effluent itself. So in the later stage, we will use a disinfection using hydrogen peroxide, and also thanks from our friends from Belinka, I see you, and Microbium for helping us scale this test. I have to tell you that we are working on 1 cubic meter per day, so these are not milliliters of hydrogen peroxide that we are using every day. Yesterday we got 200 liters for this here, so I'm very excited to test. So then we will go definitely in the second stage of filtration after this, testing Clara, thanks to Kostya and Arpi, and also Delvet machine, thanks to George, which we are already founding ourselves on the nanoscale, where we are promising to remove everything above 10 and 100 nanometers. And then we are still not done, but we are very small now. Then at the end, we will flow the water into the photocatalytic reactor, where thanks to Professor Joy and the photophantom reaction, we will try to achieve a total elimination of the nanoparticles in the water body to CO2 and water by using photocatalytic nanocoating device from KTH. So, this is the plan. I'm sure a lot of you heard my plan lately. So we will be first testing period will be 2 weeks. So the first week we will test the cascade of waste and water, disinfection, Delvet, and KTH to prove this train of on the photo, you will see a very similar setup in the room itself, where our colleagues will take you. And this is the plan for the connections for the first week. So as you see, the water of the effluent is going out also in this room. So then it goes to Ecoplex, and same retention tank, Clara and Delvet, retention tank 2, and PC reactor. So also in different locations, sensors are implemented and also different sampling points are achieved. So for the second week, we will just change to Clara's technology, and in the third week, we will use the direct effluent for the removal of nanoparticles as well. So this is something like, thanks to Vito also, Milica and Fan, how the sampling plan will look like by day, by time, who to send samples to, and how to find the correlations later between the mass, the size, the number, and the polymer types. Of course, we want to know everything. So this is our cascade solution flow sheet from the first time, where, as I mentioned, you can see also many different sampling points and also sensory technologies included. And I'm very happy to host you here today, so I can show you also this all in practice. So I see this probably, George again, please. Okay.
Yes, thank you. So now I would like to invite Mr. Konstantinou from Waste and Water. This is a company that is based in France and in Greece. He is an engineer, an experienced chemical engineer, and he will explain to us how this Ecoplex device functions.
So, I'm Nico Konstantinou. I'm representing the Waste and Water. It's based in France, based company, and I'm representing the entity of the company. Thank you, Anna Maria, for the organization of the events, and Marika, where you are, the CEO of this wonderful people for having us here and for hosting us. Our device is called the Ecoplex. It has been developed in cooperation with the Hellenic Research Center. We as a company, we try to apply some innovative ideas wherever we can and whenever we can. 90% of our business is targeted towards industrial. So this is where all the difficulties come in, and this is where our knowledge comes from, because industrial wastewater differs every time. So we have a very good experience in France and in Greece. So when the Climate Inspire project came to us, they knew that we could offer something innovative, something that has not been done before. Because that's what it takes to tackle a problem that has been recently found. It's, as you know, it's microplastics. So this started in 2020. A small pilot scale plan was manufactured because nobody knew how microplastics behave, basically. That's pretty much when it all started. That's when we found out there's a problem in some of our mosquitoes. So we started with small pilot plants. We got into sampling, we got into analysis, and it got bigger. It got so big that it can treat 1 cubic meter hour or 2 cubic meter per hour as a flow. This is it's the final unit. It has been placed in Megara city. It's a part of Athens. So we know how it works, we know how it behaves, and it has given us very good results for microplastics. It's a pretty automated device. The automation has been developed also by wastewater. It's fully skid mounted, so it can travel from country to country and from site to site. It contains of 2 different filters. One is more coarse media, and the second one is more fine media. This is again a choice of how to operate this device. You can operate it in parallel or in series. As I said, also in wastewater treatment plant for domestic use, we have brought this machine in a different country. We don't know how it's going to behave. So that's why we have 2 different stages. Maybe we work with one stage, maybe we work in parallel. This is why we need to do this. We need to put it to the test, we need to bring it to different countries and see how it behaves. The automation is there, so it's flexible, so we can operate it any way we like. Okay, some characteristics is that it can fit up to 2 cubic meters per hour and less, depending on the behavior. We can work for 24 hours a day. Obviously, there are hydrometers and all the connections to stop it or backwash it so that it operates smoothly. There has been devices that operated and treated more than 1,500 meters. So it's not so much of a pilot anymore. It's a device that is operating. It could be installed in a small hotel or even a small village. But it has been designed basically to protect the technologies that follow. So we are acting as the bodyguard of the analysis have shown 90% of microplastic removal, but that depends on what do we mean. There is microplastics, there are macroplastics, and there's nanoplastics. What we need to do is provide an effluent from our device. We provide an effluent that is free of microplastics and even microplastics more than 30 micrometers, so that the next technology can work on a nanoplastic. So, okay, we have a good retention. Again, this is a filter, so it does not provide a extraction of microplastics, but typically you can remove and retain microplastics as a device. So, obviously, when we get larger particles, it's easier for the people to take, so we get 99% reduction, also depending on the but when we start going to smaller scale, that's when we need to get the new ideas and get to nano scale. That's pretty much it. If there's any questions,
yes. No, thank you, Nikos. This is a very good introduction, and I invite now George to continue with the next solution that is also targeting tire wear. Tire wear is are very tiny particles that are produced from the tires from our cars. And there are very few technological solutions that we can apply on a global scale. So thanks to Dalbert, we have developed a very nice solution that George will explain.
Thank you. So first of all, I would like to thank George, Anna Maria, and also Mayeka and the Inspire project in general for this wonderful opportunity to develop our technology. My name is George Deliganakis. I am the CEO and one of the founding members of Dalbec. We are a company based in Thessaloniki, Greece, and we do research, development, and production of various innovative solutions for problems that are difficult for companies that are more industrial scale to tackle. So our mission is basically to bridge the lab scale solutions with industrial scale solutions with flexibility. A short introduction about what tire wear and nanoplastics are. So we have wear and tear either on car tires or on plastic litter that finds its way into marine or riverine bodies and eventually ends up into crops, into animals, into ecosystems, and eventually even into humans. This today has been recognized as a very serious problem that affects both ecosystems and human health. A very recent study of 2025 showed that the average person in Europe and worldwide is probably even worse, has up to almost 0.5% by weight of their brain tissue infected with microplastics, and 90% of that fraction is actually nanoplastics. So, what are we suggesting as a solution to this? Filtration is a very difficult thing for plastics of this size. Conventional filtering devices are completely unable to capture the nanofraction of microplastics. Basically, anything smaller than 200 nanometers just goes straight through and is absorbed by plants and organisms. Within the Inspire program, we were able to take our device from, we are using the TRL terminology. This is an European standard of readiness level of a given innovation for deployment. So we were able to take our technology from a concept, which is TRL3, to a lab testing of our prototype, which is TRL5, to a pilot demo within the lab, which is TRL6, and finally here, as you will see very shortly, it is the first deployment of our prototype in real-world scale-up conditions. a short description of our device and what it attempts to do. You will see it in action a bit later. It consists of two filtering units. The first one is a pre-filtering because in case something, a bigger size of debris has escaped previous filtration devices, we cannot risk it clogging the nanofilter, so we have a pre-filtration stage. And then we have the nanofiltration stage where we have a custom developed technology that traps and collects all nanotileware and nanoplastics of scales of 100 nanometers down to 10 nanometers. This is what the device looks like, but you will see it very shortly as well. This is how we conducted the large-scale tests. Basically, we found both real tileware and our own proprietary material mimicking tileware, which makes it easier to measure the tileware and the efficiency of the filter, because a secondary challenge we faced was how to actually measure the efficiency of the filter itself, because not only are they very difficult to capture, but they are very difficult to measure in proper situations. So we spiked that water with these custom nanotileware particles. We passed them through the filter, and then we used our lab measuring technologies in order to validate the efficiency. And I'm very proud to say that we have achieved in these concentrations almost a complete removal of all nanotileware, nanoplastics down to 10 nanometers. So this is a very brief presentation of what we are attempting to do. Thank you very much again for your attention and the opportunity. And I think we will take questions later. I believe so. Okay, thank you very much.
Because you will start accusing me that I'm only using tricks. I will now pass to a Slovenian solution. So it's a pleasure for me to introduce to you Mr. Kostja. So he and of course his colleague Mr. Arpi Talasi. He explained to me that he's from Hungary, but he lives in Denmark and operates globally, also in the United States. Welcome. And we are, they will explain us about the Clara One solution.
So, thank you to all. My name is Kostja Klaven. I'm founder of Clara. We are an interdisciplinary team passionate about sustainability, circular economy. Myself as an economist, Daniel as a chemical engineer, and also a mechanical engineer as a team. We are team is truly care about environment, so we are on the mission to reduce the microplastic pollution. As I mentioned, as an economist, I don't want to present just the technology behind, but also my learning experience on the market. So, one of the main learning from the market in the start, for me, it was when I conducted a survey about single-use plastic bottle. And I interviewed many people and I asked them, are you worried about the problem of single-use plastic bottle? And 90% say yes. But are you still buying single-use plastic bottle? And they say yes. Okay, why are you still buying it? Because it's convenient, no? It's not convenient to carry out a bottle, a reusable bottle, compared to a plastic bottle that we can easily drop in a first waste. So the conclusion is most of the people still choose convenience over sustainability, even we know that sustainability is really important these days. The next step for me it was understanding the awareness of microplastic, why people they know that they are enduring microplastic on each day, on drinking tap water, while they are not making any steps forward. And I understood that what I don't see, the brain doesn't process. No? The people that don't see the microplastic, no? Since they don't see this as a danger for our health, no? They cannot feel, no, unhealthy because they are drinking microplastics. And the last one, as an economist, for me, the most important one, it was when I had the opportunity to speak with a sustainable operator of Alliance Laundry, who hold 39% of the global laundry market. And I asked them, are you aware about the microplastic problem? And he said, yes. Are you interested in microplastic filter? No. Why not? Because we cannot make money by stopping the microplastic. And then he said, we are not going to invest in microplastic filter till this is going to be mandatory by law. So what we are currently doing to solve the microplastic problem at the stage, are many of you know, there exist two main hotspots for microplastic, over the tires, where also laundries and marinas where they are washing boats. At this stage, we are demonstrating that with our technology, we can efficiently remove the microplastics from a wastewater in marina, and currently we're demonstrating this in Marina Isola, and in September we're going to demonstrate in a soccer laundry in Germany, where they are washing just soccer jerseys, that are made just with plastics. So let's move to the technology-wise. So looking for more suitable solution to develop a microplastic filter, we were looking to find convenience, easy to use, and also solution that hopefully in the future will find a product market fit. So we decided to go for a silicon carbide membrane, which is really difficult to produce. This is why we are collaborating with RP. At the presentation, we are going to how the device is working. Now, this is something I want to like to introduce you here the device. But how this silicon carbide membrane works, RP will present to you, and then why we choose this solution.
Thank you, Christian. Thank you also for the opportunity. Just a small explanation. So we are the manufacturer of the silicon carbide membranes. We have a Danish-based company with also an operation in the US. We have two factories, one in the US and one is in Denmark, and we cover the world with all of these products. We have been around for more than 10 years, so 2014 we have established a company in Denmark, and we are always partnering up with companies like Kostya's company, so OEM companies, because they would like to achieve that this membrane technology is being integrated into existing water treatment plants. So why silicon carbide? It's a very good question. Thank you, Costa, for giving me the opportunity to talk about a little bit about silicon carbide. Silicon carbide has basically three main properties, which makes them an excellent solution for water treatment. The first one is the high flux rate. If you are a little bit aware of flux rate and membrane technology, then you know that the higher the flux rate is, the less surface filtration surface you need. So which means that also it influences somehow the size of the plant, the OPEX, the CAPEX, the ownership costs, and a lot of other things. This is a low organic absorption. The low organic absorption is coming from the properties of the material itself. We are dealing with a slightly negatively charged material. So silicon carbide is a slightly negatively charged material, so which means that
there is no irreversible fouling, very less irreversible fouling, which means that there is no drop in the substrate over time. So we can really use the same substrate from the beginning of up to 10 years, 15 years, 20 years. And then the third one is a chemically inert material, which means that it has something to do with the production. I will come back to this in the last slide. The chemically inertness means that we can really work with in very extreme circumstances, which means the pH value can be between 2 and 13, and you can really have an aggressive cleaning material that we can use ozone, and you can use a lot of other things, which also means that the cleaning of the membranes is really possible. Just an example why we think that this is a good solution. The footprint question is always a big topic. So the conventional water treatment plant looks like that. So you have a fine stream, you have a coagulation phase, flocculation, sedimentation, and multimedia filter, maybe combined in the cartridge filter. When we are talking about wastewater treatment plant like Gonzale right now, so we can see that this is the tertiary part. Treatments of the secondary effluent, you get to this point. So when it comes to ceramic membrane, you can get rid of the fine stream, you can get rid of the flocculation, you can get rid of the sedimentation, and both multimedia filter and cartridge filter, and you can replace it with one single ceramic membrane solution. So you don't need anything else. And the plant is still delivering a stable and good effluent water quality. So there are no trade-offs on this. You can really use that. You can really simplify your treatment chain. You can look at when it comes to extension, so to such kind of solution. When it comes to comparison with conventional technologies, and we can see that I just made a comparison between sun filter polymeric membranes, ceramic membranes. Sun filters have been around for 70 years. Everyone knows that it's a robust technology, but it has its limitations. It's a microfiltration basically. It has a high chemical consumption, and it has also huge waste when it comes to backwash. When it comes to polymeric membranes, they have better effluent water quality, but it is still sensitive. It is still not robust as the sun filter. And the ceramic membranes, the silicon carbide ceramic membranes, can combine the advantages of both technologies, which means that the small footprint, we have a good chemical resistance and also good water quality. And I have just one more slide, which is important maybe in this context. Before you start producing silicon carbide in your backyard, just consider some things what is important. So this is a really intensive process. We have a sintering multi-glucoside decoder, which is coming from the mining site in Norway. We are using more than 2,000 degrees Celsius for the production. We need really precision engineering. We have a lot of material scientists in our company, and we have to control also the pore size distribution. So this is a really sophisticated one. If you know how it works, then it's not any more than sophisticated, but this is a huge investment. The investment cost for our US factory, we opened 3 years ago, it was around $50 million US dollar. So this is some special things. But in the last 10-15 years, the ceramic membranes became really I would say not a common technology, but it's even a more standard technology than it was before, because we had a lot of investment, not just we, but also other companies. And the price of the ceramic is going down. So now it is really an economical available solution.
So we are here to show the details of silicon carbide membrane in with the device we developed, but as well, with the University of Maribor, we want to model and show the performance in full-scale plant operation in Gonzale wastewater treatment plant. Thank you.
Thank you very much. So you see that we are progressing and we are going smaller scale. We have achieved up to 10 nanometers. 1 nano is 1 billion meters. So we're talking for really very small particles, undetectable practically. And it is a pleasure for me to introduce to you Professor Zoe Dada from KTH Royal Institute of Technology in Stockholm, in Sweden, that all these devices will somehow capture these microplastics, but thanks to his technology, we will be able to completely eliminate them. So, he will explain us how.
Thank you. So my name is Joydeep Datta. I'm from KTH. For those of you who don't know our university, we are top 10 engineering school in Europe and top 100 in the world as a complete university. We are small, about 18,000 students, but we have a very large research base. Professors and researchers are about 1,000 people, and then we have 3,000 or slightly less PhD students. So it's a research-intensive university, wherein a non-researcher who wants to take ideas from the mind to practice, that's me. So essentially, the reason behind is that for me, survival is not a choice, not a chance, it's mandatory. And it is our task to come up with ideas, to be able to translate into profitable businesses that can also assist in reducing pollution. So I'll take you through a walk on what I've been doing for the past 25 years. Photocatalysis. All of you have seen it. If you keep a plastic bag under the sun, after a few months, especially in Slovenia, it will work very well, your plastic bag will start breaking up. That means you are degrading the plastic. If by any chance you had that plastic bag sticking on to a rusty nail, you will see that degradation is much faster. Because this rusty nail is nothing but iron oxide, which is a semiconductor, and it does what we call photocatalysis, or it produces electrons that can increase the degradation process. This is how I started, because my background is designing integrated circuits. That's how I started my career. So I think about electrons and how they communicate. So from chips to water treatment has been a long pathway, but I think both are important. So what we have done, this is about 25 years back in Thailand, is we tested reasonably small, it was 60 centimeter by 30 centimeter, I called it prototype those days, for testing the textile wastewater, which was becoming a problem there. And it seemed to work. And then I thought, it works, it's fine, but if I look slightly in detail, if you look at it, if I have Fenton reactions going on, then I can accelerate this process. For those of you who don't know Fenton reactions, don't worry, I'll explain you in a nutshell. So I was not happy that it takes 20 days or 30 days for degradation of anything. I want it fast. Then I met George during that time, and the questions of microplastic degradation came in. And we started working on it about a decade back. The concept with which we work, all of you who are in wastewater treatment know what is Fenton reaction. It's about iron 2+, iron 3+ transition. It's fair and simple. But the whole process is that the iron 3+ has to go back into iron 2+. In a sense, you have to supplement some hydrogen peroxide in order to do that. And in the process, you make some oxide and hydroxides, and that get back into the water. Any contaminant in the water is very bad, and if I produce some contaminant while I'm degrading the microplastics or doing some work in the water, is even worse. So then we started thinking, can we have heterogeneous catalysis? Don't worry about the words. Again, if I have some support on which my particles are stuck in, then in that case they will not precipitate and go back to the water. So with that receipt, we built up a reactor. And since I had this photocatalysis part in my mind already, I was thinking, can I save some hydrogen peroxide? And that's what we saw, that you can save up to about a quarter of hydrogen peroxide if you take the help of the sun. One thing, I don't want to make any sludge. And second thing is I want to get more or less things done for free. So the sun should work. And that is what we have been working on. And we have done several types of things. So this is what we have done with clean project. That was another commissions project in which we clearly showed that polyvinyl chloride we could reduce from 70 micron to about 30 micron within a week. Polypropylene, which has got a lifetime of over 500 years, that one we could degrade from about 150 micron to 50 micron within a week. Okay? So this was a major achievement. But you know, I'm never happy. So first thing first, try to see, can I have some new processes by which we can activate the photocatalytic process. We don't make any sludge, so we came with a molecular switch. So we came with some special crystals in which the Fenton reaction takes place inside the crystal. So the iron is plugged in the crystal, and that loses an electron and gains an electron. So in that case, I get rid of the sludge totally. And that's typically what you have in this plug, which we have already sent. And we immediately see that we are much, much better compared to before. Within a couple of days of continuous irradiation, we are more or less taking away all the particles that we started off with. Now please, these numbers here, 260, 350, is just because that's the plastic I had in the lab. So whatever I had, I put it in. Okay? Well, we will see how it works. We have over-designed a bit the system because, you know, we are university people, we don't want to make profit. So I'm quite confident that 1 cubic meter will not be any problem at all because I have over-designed 5 times the size. Because normally people say that if you are from university, you are not used to pilots, but I think we are. Thank you very much for your attention.
So all these are very stimulating, and thank you very much. I would like to start a small debate among us now, and so I would like to ask Anna Maria what are the specific benefits from this cascade solution over conventional treatment methods. Please talk to our audience.
Yes, thank you. What was the question?
I mean, what are the specific benefits of this cascade solution over the conventional treatment?
Okay. Thank you very much. As we all know, the conventional treatment methods do not focus on microplastic, nanoplastic particles and also other pollutants. yet, I would say, but with good support with people like Marietta, I know they're preparing also to integrate the fourth cleaning stage into the wastewater treatment plant of Manjala, where they will be tackling also the leftovers of the chemicals and other micropollutants in the water.
Thank you. Great. So, how adaptable do you think this model is to the different wastewater treatment plants across Europe?
Well, I would say after analyzing the first results of Marietta's water, I'm sorry to call it like this, but we have basically realized that the water qualities are quite similar if we compare the Slovenian wastewater treatment plant with the different ones. So if we will manage to prove with the help of these beautiful people here to really pull off this experiment, I think the scalability and the replications are in a very good process to proceed.
We have now a new wastewater treatment regulation. I think that is foreseen a fourth dimension of treatment in most European wastewater treatment plants. So apparently, these cascade solutions could have potentially place. And I know that in your work package, you're working a lot with LCA and all these novel tools. So, what are your next steps in validating or deploying these solutions?
Okay, so what we would like to do is, of course, obtain the data from the field, which we are doing right now. Then try to integrate all the data together, of course, with the support of the University of Wageningen from the Netherlands. We would like to simulate, for example, if we take into consideration Kamniška Bistrica, small but ours, we would like to simulate from the outflow of the river till it goes to the next river and then later, where are the hotspots, how many, how much polluted water is getting with microplastics, and then also try to model what are the constraints that we should apply in order to achieve the 30% reduction of microplastic to 2030 in the whole river length.
Thank you. So, Nikos, I'm wondering, you showed us very nice results from the CLAIM project, which make us confident that we will be able to withhold, if you wish, to act like a bodyguard, as you nicely mentioned. But what is the new things that we're going to do in Inspire here?
We have upgraded the device in terms of instrumentation, and also we have brand new media, which is more fine. We can see that in this plant, the effluent is pretty clear. You can hardly differentiate it from other media. What we have to work with was much worse situation where the filter could blow in seconds. We need to adapt. We need to make changes. So it's an upgrade for the filter because we'll be able to filter in a better way. With the new
and I'm the third microns.
Yes, it used to be more than 50 microns, and now we're expecting to move more than 30 microns.
Very nice. And from your experience so far, what are the stakeholders' perspective for the installation of such devices, and what could be our proposal in order to upgrade the system and treat 100% of this water? Because so far we have a limitation of 30 to 50 liters per day, but how are we going to assist our colleagues here to filter 100% of their water?
This is a teamwork that needs to be done. All the technologies need to be developed further go larger. And this is why we do the display. We need to get the data from display, and then it's just engineering the design to go to anything that we want. obviously there are financial limitations of that and commercial issues. But as a technology, I believe that anything can be done.
Thank you. And George, congratulations. I think that the achievement to go down to 10 nanometers is really fantastic. But, okay, this will be very nice. We can demonstrate it here in Romania also. But how do you think we can pass all this technology to the real economy, to the real world? What will be our proposal to the highway authorities or to the regional authorities? How we should, what sort of investments need to be done in order to integrate the solution into the daily life and to, if you wish, the standards that each highway and road should follow in order to incorporate these solutions and mitigate the problem of tire wear.
So as I said before, the device was designed to bridge the large-scale problem towards the industrial-scale problem, and thus it is designed in a modular way and also with a relatively reduced footprint comparable to the volume of water that it fits, which is 1 cubic meter per hour. It is quite flexible. It is able to fit on the roadside. It is able to fit in industrial facilities. It is able to fit in remote locations. Secondly, it is machine designed up to modern standard, which means that besides its very high efficiency, as you saw, it is able to be monitored remotely. It is able to provide data collection remotely, and of course, the important part is that it is able to future-proof compliance with upcoming European regulations in the next few decades with microplastic and nanoplastic content in water for all these facilities. And a very important part also is that because it is designed in such a way that it can be retrofitted in existing systems, the treatment plant, the highway authorities, they do not need to redesign their entire pipeline of effluent. It can just be installed, and it has very low maintenance, very high efficiency, so it's a very low ownership cost solution for those organizations.
Thank you very much.
Thank you.
Thank you, George. So for our friends from Kerawan, we all know that initially many people would say, okay, you're using a membrane, now this might float very easily or it might foul very easily. What is your answer to this criticism and how our systems in Inspire will provide realistic solutions to these problems?
So we implemented a backwash. Maybe Daniel, our colleague was a chemical engineer, will explain the final backwash and the chemical we're going to use and how.
Should I come there? Just
Yes,
can I speak?
whatever you want.
I can speak from there. Okay. So we'll just do quick backwashes in order to prevent some clogging during the operations. And once a day, we do a general backwash using hydrogen peroxide in order to prevent fouling and disinfect all the system basically. So
no problem.
Yeah.
I was really amazed to hear by your colleague that this carbide mixture that you're using can really replace the sound, which is a major breakthrough, I think. So, can you tell us, for example, 1 square meter of this filter, how many kilos of sand it can replace, for example?
So we are talking about 2 different types of filtration. So the sand filter is a microfiltration, which can filter anything which is, I would say, below or above the 5 micrometers, 10 micrometers. So this is the limitation. So we are going once we are under this level, we are on 0.1 micrometer. So this is something that needs to be done. So when it comes to gravity sand filters and not pressurized sand filters, the footprint is around 1/10 to 1/20. So 5 to 10% of the initial footprint. This is the I think the more accurate number of testing for some filters.
That's nice.
Yeah, it is.
So, do you think that your technology is suited also for decentralized or mobile applications?
Yes, we are currently using it as a decentralized treatment in Marina, in Isola, and also this program can be used in the last pool now in our resulting plant. So everything's possible, as a machine or as a decentralized.
Very nice. So, thank you very much. So, I would like to ask Professor Gata, what is the functional lifespan of this analytic coating that you are applying?
Well, we haven't tested like my industry colleagues in industrial conditions, but I have been testing it in the lab. And we roughly believe from the measurements, we see that it can last at least a year. But we will have to really see that. I don't want to make a statement before I've repeated this experimental text, how careful I am.
So I noticed that you mentioned that we get rid of slabs and we did not admit any chemicals. But are there any risks of nanoparticle leaching or environmental impact? I believe we have tested the claim also.
Yeah. Any crystal will definitely leach some part of its elements in very harsh conditions. We normally check the stability by diagram, which is called the Courbet diagram. So when you look at the Courbet diagram of the crystals that I'm using, it doesn't show any distribution. But when I've checked after continuously running for a month, I see, yes, there are some iron, but iron is not so bad for the fish. They can survive. Okay? So, however, when you are making a small particle, we have to go up to the carbonization. That means when there is nothing left. It's very difficult to analytically see. So I don't know. That's why you will see that I've gone up to 90% and stopped there. Because beyond that, even my good microscopes, you cannot see it. So that's the catch-22 situation that we are in. But it's definitely going to lower the effects because it doesn't produce the virus. We tested that.
Yes. We had some experiments also with toxicity, and they were really okay.
And by the way, this is nothing very special. It's not only for the plastic. I am testing it for drugs and for pharmaceutical APIs. Okay? And of course it was, because this is nothing but advanced oxidation process, but I call it AAA, advanced oxidation process.
So, the question of $1 million. How many days do we need in a sunny place like this to complete so microplastic?
Okay. By the way, I've changed since Anna Maria made me aware that Slovenia is not as sunny as I had seen last summer in the winter time. So I changed the design slightly. If we don't have the sun, we will be 25% less efficient. Okay? So talking about the days,
we need the sun.
No, if we don't have the sun,
We can go for another exactly. This is what I wanted to say.
It will still in this design. I can't tell you more because I'm just submitting a paper.
Oh, nice.
But it's the target is I don't want to make Volkswagen at the price of the Rolls-Royce.
Yes.
So these are very cheap. It's definitely not as expensive as the silicon carbide membranes because I am from silicon carbide technology myself, long back, 30 years back. Huh? So, but it's an excellent membrane, we know, because it can sustain very harsh environment. The way I'm designing cannot sustain harsh environment. Acidic, no problem. But basic, beyond 8, I don't know.
By harsh environment, what exactly?
Harsh means high pH. Chemists use high pH means lower the pH value, it's higher. So up to pH 2 we have tested, the leaching is minimal.
Yeah, I think it's hard to reach this extreme level.
Oh no, it is very we are testing now in the paper mill. So
yeah, I mean not in a normal municipal wastewater, but rather more special treatment plants.
I don't envy our friend, the CEO of the treatment plant, because she gets all the mixtures.
Yeah.
It's even worse than doing the industry.
Unpredictable inflows of whatever you can find. Thank you very much.
Thanks.
I think we are 5 minutes before our time finishes. Or is there any question that you would like to ask at this stage? Okay, if not, thank you very much. I thank my super panel, and I think that we can proceed to the next to the program and to the visits. So up to you now, Maria. Thank you very much.
So thank you very much, George, and all the colleagues presenting your work. I'm really optimistic. So now we will definitely proceed to the on-site showcase of Inspire Cascade Solutions. We have organized these visits in groups. I'm sure my team gave some reasons, but they will categorize you in groups because the room is not as big, so we can fit all in. For the others that will be in the waiting mode, it won't be boring for you because we have prepared some refreshments for you, so you can just relax a little bit, network, experience some knowledge, and then I will see you back here at 1 p.m. Thank you very much. You are there. Hi.
Test, 1, test, proba, test, proba. Test, 1, 2.
Oh,
Thank you very much for returning to the sessions. I hope you had a nice lunch and that you refreshed yourselves a little bit. So here we are at the first roundtable in this afternoon sessions, where we will be diving into the topic how to tackle or address microplastics in wastewater treatment, emerging technologies, analytical tools, and also the digitalization part itself. So for this roundtable, we have invited Inspire partners who are also part of the project, not directly developing technologies that you've seen before, but supporting in many different ways the development of this project, which I'm really thankful for. As we know, microplastic persists in treated water and threatens the ecosystem across Europe and the Mediterranean. So today we have assembled researchers, analytics, digital innovation, and infrastructure across Romania, Belgium, Greece, and Italy, Slovenia also, yeah. With our joint goal is to explore and also test not only what works in the laboratory, but also in the environment. So maybe let's begin with a quick tour de table.
Good afternoon, my name is Vanessa Moschino. I'm here in behalf of Fantina Riccardo. I'm from the Italian National Research Council, and I'm involved in the INSPAC project because CNR is the democratic leader of the Po River. So we are with also George and another partners developing and implementing hybrid technology to collect and collect marine riverine ethers for their in marine environment. I'm also an expert in microplastic sampling and analysis. So it's one of the targets that we are studying also in the program case. And
thank you very much. Vanessa, also thank you for coming. I was supposed to be here, but unfortunately, due to some events, we're very glad to. So, Marco?
My name is Marco Petini from the SME for Data based in Italy. We are partner of Inspire project for the digitalization and the data management. In specific, we take care of collecting the data from different technology partners, harmonize the data to make it accessible and comparable also with other data sets for the scientific community. Specifically, we also support also the mosaic leaders and technology provider by connecting sensors and all other meters to collect additional data and help them to understand how they can optimize and improve, make more efficient the retention, in this case, of microplastics.
Thank you, Marco. George?
I'm George Timothy's. I'm the CEO of a spin-off company at the Academic Center of Marine Research that is called Mines, Technologies and Environmental Sciences. In Inspire, I'm the Work Package 2 leader. Work Package 2 is focusing on the installation and implementation of a series of technologies in 6 major European rivers. And I will have a presentation shortly to give the details of what we're doing in Inspire.
Thank you.
And I'm Yu Fan. I'm from Brussels in Belgium. I'm from the Special Lab of Inorganic and Organic Lab. And here we will also partner with Inspire and we support with analytical to measure nanoplastic. So especially in the Domzel case, we will be testing the efficiency of different technology in micro and nanoplastic. So we measure the plastic concentration before and after the technology treatment and reducing the efficiency.
Thank you very much.
I'm Aureliano Antonio. I'm from Romanian Water Association, our organization
We include 46 regional operators of water, particularly all regional operators of Romania, and around 150 private companies who are involved in the water sectors. In Inspire, we have 2 demo cases in Romania. One of them is on the Danube at the wastewater treatment plant to Fătești, and in the next period we will continue what beginning today to testing this technology at the wastewater treatment plant in Fătești. And I think that it's important to participate in this project because we can be involved to be a solution, not only a part of the problem.
Thank you very much. So now I would kindly ask George, somebody who is basically pioneering these advanced removal technologies and lead us through all this jungle, to present a bit broader overview.
So yes, here I have a brief introduction on the world of the microplastic technologies. So in Inspire, though, we are doing a lot more. As in the morning session we heard from Anna Maria, we are working in the so-called DCP concept, which is the detection of the litter, the collection, but also the prevention technologies. How to change the mindset, or how to make easier for the consumers to have less plastic in our daily life. So for the detection of the litter, very briefly, we are installing cameras from which we are detecting with AI the microplastic pollution. We also install these cameras in drones. We have specific applications, and we also do in situ samplings in order to better understand the status quo of the plastic pollution at both macro and micro level in the different use cases, and what can be done afterwards after applying the Inspire technologies. Also, we are doing the collection of the litter. We are using, for example, screws and nets, practically, floating booms that stop the plastic litter and guide them into collection devices, but we also do citizen engagement, and we apply rotation wheels, all sorts of mechanized solutions to concentrate the plastic litter. We also do filtering work, like we are applying here in Gonzale. And we have reactors with which we completely dissolve the microplastics, and we're using much more environmental friendly products. So we try to substitute the plastic pollution with substances that are easier biodegraded. KTH is developing also coatings for food items, because we can replace like that the plastic packaging that is applying in various fruits, and like that reduce the amount of plastic that we consume. Also in cosmetics, we replace microplastics with products that are more environmental friendly and not contain any microplastics. And we use a series of zero waste solutions. We are making interventions in 6 major European rivers, in the Rhine River in the Netherlands, in the Scheldt River in Belgium, in the Douro River in Portugal, in the Po River in Italy, in the Danube River in Romania, and here in Kapniska Bistrica River. I will never be able
by the end of the process.
Hopefully, please excuse me for this. We will all try to develop a master plan of how exactly, what are the investments that are needed in order to make a realization for all this. Because, dear friends, let's be frank among us. We need serious investments in tackling the plastic pollution. This is an overview of the 7 work packages of the INSPIRE project, and I'm leading work package 2, which is the plastic prevention and collection from rivers. So we see we have 3 major routes: the preparation phase, the installation phase, and the implementation phase. We are practically now in the installation and implementation phase in work package 2, and we will feed these results to the colleagues of the other work packages to further upscale these solutions, how to transform them into the real life actually. So, as you have seen today here in Gonzales, we are applying these 4 technologies that can lead us up to 10 nanometers. This is a significant breakthrough, I think, because it allows us to really go very low and even eliminate them completely with the photocatalytic reactor. Then in Romania, we are operating, as Aurelian briefly mentioned, in a wastewater treatment plant that is called Fetesti. And nearby this area, there is a very big highway, which you can see a small video here, how it looks like. So it's in a downhill area together with tolls, so everybody stops there, so they apply also brakes. Every time we accelerate our cars, we produce tiny tire wear particles, which with the first rain they will be washed, and you will see through this drainage channel they will be concentrated in this yellow pin there that you have seen in the beginning of the video, and we will collect the so-called storm water, which will be full of the tire wear. This will be treated with a Delta device that will be specifically devised for the testing, after passing everything, of course, from the bodyguard. I think that's the word of the day. For the waste and water Ecoplex device that will safeguard the good functioning of the more fragile waste devices. So we can go, as you have seen, George said, reported the 10 nanometer. This is an amazing number, I think. Then we operate in the Douro River in Porto, in Portugal. It will be here a marina. So this is the sea here. So downstream from the river, it is this Freixo marina where we will apply a series of filtration technologies over there to collect all the microplastics that are, or the paint, the colors of from the paints that are not that environmental friendly, as you know, because we are trying to put these anti-fouling paintings in order not the boats to have have an anti-fouling effect. And all this, after washing these vessels, end up unfortunately in our rivers. So we want to apply our technologies in order to withhold this pollution from there. And these are the main interventions in the microplastic scale. Thank you very much.
Okay, so thank you, George, for this very interesting presentation. Now, as you can see, microplastics is flowing into our environments through many sources, which under the INSPIRE project we have tried to comprise as many as we could, and also to find the solutions for them and implement them. Now, maybe we start with Aurelia, because you feel like it's the last always. So, from a water association standpoint, okay, how are you preparing your association and all the, I know you have many wastewater treatment plants involved into the new wastewater directive that is upcoming?
After many discussions in this project and with regional water operators, I
for that we have need some money. And
William, can you speak a bit louder, please?
Yes, of course. I tried. And for that, I think that this process must be helped by subsidies, through subsidies and other financial instruments to have money for research and for improve this technology at a large scale, because it's a major problem. The second point are regarding to educating the public. And this is the major factors, because in this way we can reduce plastic use and properly sort the waste. The third point are enforcing regulation to control the use of plastic in all quotidian activities, in agricultural field, common activities. And the fourth part, very important, is collaborating with researchers and to stimulate the program to engage researchers shoulder by shoulder with regional operators, with municipalities, with governmental institutions, and to have an integrated action.
Thank you very much. Yes, I think you summarized everything very well. What I wanted to maybe refer back to, when you said you needed to upgrade the existing wastewater treatment plant even before starting about microplastic removal. So where are we now? I mean, you as the Romanian Association of Wastewaters, what kind of treatments do you mostly use at this point?
In this point, we have the major regional operators. We have the third phase process of trade water.
Okay, tertiary.
Yes, but we are prepared to go ahead,
okay.
And we are open to implement new technologies to resolve the problem.
Yes, okay, one more thing, I'm really interested in this topic. So, when the new wastewater directive will come in place, there will be a lot of, investments for you, as you mentioned before. How are you tackling this problem? I mean, are you going to go and do the upgrade all at once, or are you going one by one, or what is the plan?
Then we try to have an integrated action plan for all regional operators. In the next week, for example, we will have a workshop about to discuss this action plan with the major institutions, governmental institutions, National Water Authority, and National Authority of Protected Areas, and many municipalities. This action plan wants to find a solution to finance this program, because it's a major issue now, the financing this process.
Yeah.
Upgrade. Now we have many discussions with these authorities to manage that in the next 5, 6, 7, 10 years, because it's important to go together technology and financing the program to improve the technology. Yes. Now, I think that it's important to convince the governmental institutions, municipalities, and the Commission to allocate important financial resources to this process.
I think that what you mentioned is a very critical step forward, because things are not that easy. Because I think the new directive talks also about energy efficiency, that the wastewater treatment plants need to produce their own energy, or to safeguard that there will be energy equivalent
which means that most probably they might have to install, I don't know, photovoltaic or other systems, which means that if we will add also that the so-called fourth dimension of treatment will not only involve microplastics, but also PFAS and pharmaceuticals and everything that ends up there, and now we cannot treat them, actually. I hope they will impose some limits, but we might need additional space. I don't know if in the major cities we do have this additional space for installing all these additional facilities. So I think we have to see case per case. It's not a one size fits for all. But what do you plan to do in Italy actually?
I want to make a comment because if I'm not wrong, the directive for microplastic asks for the monitoring of the microplastic in the large, but not for implementing technologies to collect and retain them. And I think that this could be an issue because we need to implement the technologies, and the directive asks for the monitoring. So it's somehow lacking in some points.
Which directive for the
The
plastic?
waste water, the new.
They're talking also that at least in the previous
I don't know
edition.
if I'm wrong on this.
Our regional operators respect the level of parameters of the water treatment directive, but we want to go ahead to renew.
Okay. So that
yes. I have another comment regarding the energy demand of the big energy demand of wastewater treatment plants. Nowadays, also I think promising using of digital twins and artificial intelligence that some study demonstrated that can increase power saving up to 40%. This by collecting before the data on how pumps and other machinery consume inside the different steps of the filtering process, and then with the IE machine learning generate some prediction and scenarios on how we can reduce the energy consumption. So maybe a combination of green energy source and use also of artificial intelligence can help to tackle better this issue.
Thank you, Marco. Very good. You answered my question already without even asking. This means we talk enough. So I wrote this down. So where do you see that basically you're telling artificial intelligence, modeling, and Internet of Things combined together into one system could definitely save energy for the big system of the wastewater treatment plants. But do you see other choices where can we optimize the systems?
I want to still put some comment on this digital twin concept. Now we have also this time first test digital and then invest in real world. Why? Because as maybe the water operators knows, the investment in the water treatment plants are huge. So the digital twin can help wastewater treatment plants to before an investment to first digitally, virtually test simulate how the new systems can work, and so the digital twin can help also to make some simulations and help in decision making before a real investment, and also helps obviously also to make the right choice to invest on the correct machinery systems. Then we have obviously then Internet of Things, smart sensors, all this technology that can be connected to standard mechanical and analogical machinery, and this also can give a lot of insight because computers are really fast to elaborate, and now with this emerging machine learning, artificial intelligence, obviously that we can some optimization procedures, actions can emerge with much easier.
Okay, maybe one question. Unfortunately, we all know the big catastrophe that happened here at the Jala wastewater treatment not that long ago. Could artificial intelligence also help us predict extreme scenarios in the future?
Yes, sure. Also nowadays there are already some studies and some researches where we use different water sensors, and if we put in combination different water sensors, we generate a virtual matrix where in combination of different water parameters we can guess if there is some emerging pathogen or contaminant in the waters. And artificial intelligence can also predict how will increase in the coming time, hours or days of these contaminant levels, and help to act before a disaster happens.
Okay. Thank you very much. So there's a lot of applications still available. How to integrate the artificial intelligence in this kind of big systems, but it could definitely help us operate in a way that it's less risky. As you mentioned, the monitoring, we're back to the monitoring. Yes.
So all these systems, the models, the digital system need to be fed with environmental data. So the validation of the system is really important, and they need the environmental data and comparable environmental data. So we need for microplastic in particular, because for microplastic we have more valid, more standardized, not always standardized, but more standardized protocols for microplastic and more for nanoplastic that are really a problem also to detect and the process protocols to detect nanoplastic are still a little weak. And so we need the environmental data, but we need really strong environmental data comparable from different regions, from different places, because and also using different methodologies. Because for the microplastic, sometimes we use instruments that collect only fraction of microplastic, and sometimes also the scientific paper don't highlight really well the target of their analysis. So sometimes it's really difficult to compare the data from different studies, from different areas, also from area of the same country. So this is really, really important. I think that within SPAR we are really trying to standardize all the protocols of the procedures to at the end have comparable microplastic concentration and data transparent also environmental analysis. So this is really, really important.
Yes, definitely, Vanessa, thank you. I would agree. But luckily for us, we have an expert in analytical chemistry here with us who can definitely maybe tell us something about this topic and how do you see the methods being standardized at this point in Europe and how much reliable measures we can get across the European Union.
Yes, so I think at the moment the microplastic and nanoplastic is still not being standardized. There is on one ISO standard, but that's coming for analyzing microplastic in water. But then for more complex matrix, like wastewater or even soil sludge, then there's not yet a standardized procedure. Different lab using different procedure, using different analytical equipment. So we have a very varied data.
And then we can
Yes, so analyze different fractions, like the size dimension fraction of microplastic. So it's really sometimes chaos. you know.
So improving new protocol can help also to reduce this false positive we have with analytics.
Yeah, so for the analysis of microplastic and nanoplastic, there are many things that we need to consider, like lab contamination, because plastic is everywhere, and then different lab, they have different sensitivity of their method, based on how contaminated the lab and how sensitive it should be. That is one of the big like obstacles. And then also we have a lot of false positive results. Like because in like microplastic, it may compose of the false positive a lot of carbon and hydrogen, and also a lot of organic materials also have a lot of carbon and hydrogen. So somehow they produce like spectroscopy signal of mass spectroscopy signal that really identical, and that is why at the moment for really complex matrix, we have a lot of false negative because those organic materials being fully identified as plastic. And of course, we also have false negative, that means plastic in the environment that is there, but we cannot really identify them, either because they have a lot of chemical inside, for example, additives like antioxidant or flame retardants, and sometimes they can mask the signal of the plastic particle and make it misidentified. Or colorant being an issue in, for example, with the microenvironment technology. So yeah, lab contamination for positive or negative. So those are all the issue that micro and plastic analysis is especially for nanoplastic.
So we have to consider the contamination setting.
Yeah.
Because you mentioned not only during the analytical part of the work performed in lab, we can also have contamination during the sampling. So this is really another issue to be considered when we are collecting microplastic with different instruments in the environment.
Luckily for us here in Inspire, we have decided to use the Ferrimox, so we will use the same method now.
No, we are really so we are using also the in the Inspire project, and also with we are collecting segments. So yes, so we are using
more traditional.
More traditional, yes.
Well, my involvement in the plastic pollution issues dates from 2017, where HCMR coordinated the claim project. And from my experience, I can only remember what Socrates said which means one thing I know, that I know nothing. Unfortunately, could not be more true for the microplastic and plastic pollution. We are making steps to standardize things. I will give you one example. Perhaps you have heard for the Water Framework Directive. We have for we have the descriptors, and it's the plastic pollution. So we have the good environmental status for the marine environment. If we have less than 20 items of more than 2.5 centimeters, in order to catch also the cigarette butts in a beach, in the sea. If you will ask Vanessa how many sea counts in the riverbed, it's hundreds and thousands per 100 meters. And still at the European level, we do not have a standardized protocol for the rivers. So the MSRD stops perhaps in the marine waters. We have no descriptors for the rivers. And this is a big challenge, I think.
Yes, because the rivers now are considered one of the main environment where microplastic and macroplastic can accumulate. So yes, we perform this cleanup activity in the whole riverland, and we found a lot of historically accumulated plastic items, because there were also the colored, so they are not produced anymore since the 80s, I think. And there are a lot of, yeah, there. So I think that it's fundamental to implement also the legislation because a lot of data that we have now for the marine environment derives from the monitoring from the Marine Strategic Framework Directive. And the fact that we don't have enough data for freshwater environment is also because this is not included in the Water Framework Directive as a descriptor. So as researcher, we have to do the environmental monitoring, but also we have to press for the implementation of the directives, the European directives that can help us also to have more data because in Amazon portal, all the data about which litter are collected and they are comparable. And we don't have the same thing for the rivers. And this is because the plastic litter and the marine litter are one of the descriptor of the marine strategy framework. It's also the implementation of the European legislation is very, very important, both for microplastic and the microplastic.
Thank you. So basically, you're telling me you don't have a legislation, you don't know how to measure it, so you have no idea what it's in there, but we're still, we know it's there.
We're trying to develop the analytical data and reproducible and accurate analysis. Yeah, but it's still in progress.
Can you maybe refer what are your plans for Vito, how to tackle the nanoparticles below the 40 microns in the SPIRE project?
Yes, so below 40 microns, so that involve both micro and plastic. So for microplastic, we can do like mass analysis or also particle analysis with FTIR, micro or transform infrared. We also have microgrammar at Vito that can do mapping, quantifying, identifying what kind of plastic are there, what is the concentration, what is the shape of the fiber and particles. And for mass, at Vito we have pyrolysis gas chromatography mass spectroscopy that we can like with this technique we really like pyrolyze the plastic in small monomer, like small pyrolyzed product, and then we identify them with the mass spectrometry. So we can also report mass concentration and plastic. And for nanoplastic, we also can do some sort of enrichment. Let's say enrichment to really have a sufficient amount of nanoparticles, and then we also can do pyrolysis PCMS again for identifying mass concentration of plastic. And for particle concentration and for like imaging the nanoparticles, at Vito we also have nanoparticle tracking analysis. We have dynamic light scattering and also SLM scanning electron microscopy and atomic clocks microscopy that can really allow us to see the nanoparticle down to the 10 nanometer. So yeah. So but the challenge again is really to reduce the lack of contamination, to really enrich so we have enough nanomaterials to analysis.
So what is enough here? Sorry.
So for example, for the pyrolysis PCMS approach, we need up to like 1 micro or over 1 microgram of the sample so that we can see them confidently, for example. So if the concentration is too low, we really need to go for some sort of simple enrichment so that we can reach the sensitivity that
Okay, this is very very interesting what you're saying, because this is still we are discussing the model water, correct? We are working with the water that we prepare the suspension so we know what's inside.
Yes.
Do you think these similar analytical methods could also work in the real waters?
Yes. So that is what we are also developing. So But for the real water, it could be a bit more challenge because we have like interference of the analysis, for example, organic matter, and this can really be false positive, for example. So that's why we have to go through such sort of sample cleanup, for example, using chemical digestion to really try to remove as much as possible and then simple enrichment, and then after that we can do the analysis. So with our pyrolysis PCMS, for example, we have a spectral library, for example, of more than 12 polymers, and we can identify what are there in the environment as long as they are in our library. And we transport.
Thank you very much. It's very innovative approach, and I'm really happy that co-create this together. So I'm good to have you on board. If we manage to prove everything that is said right now, in this case, we would know how many particles we have, also on nanoscale, which type, and also the mass. So then we know everything. Okay. So now, perfect scenario, we know everything was in one way. We will achieve this, but maybe George, I have a review question. Do you think? But wait, then you can refer to this. Do you think when we know what's in this kind of advanced monitoring things will be used in the further design of the wastewater treatment plants?
Well, yes, but I think I want to make some clarification because some of the colleagues here asked, okay, how much water do you treat in the pilot plant? And we have seen it ranges from 30 cubic meters to 1 cubic meter per day, for example. So how on earth are you going to have a clue what will happen to the environment? And I would like to clarify that we will do that by modeling work. So we have other teams that are working on models of how the plant microplastics and the plastics behave in the riverine environment. So based on different scenarios, we will give them that if you will apply this technology, you can achieve that much efficiency. And if you will do this, you will have this efficiency. So this will allow us to make different scenarios, either on how many waste treatment plants we will apply these technologies, or what will be the percent of the volumes that we will treat. And like that, we can do forecasts of what will happen to the macro and the microplastics after 1 year of implementation, after 2 years, and so on. And this is related, of course, with the investments that Aurelian mentioned. So we are trying to put all the pieces of the puzzle together, but I think you all realize that it is not either easy or cheap. Okay, there are not cheap solutions. And also because we cannot just invest on technologies that are taking out the plastics from the environment. We need to change ourselves. We need to change our habits. I mean, when I was younger, we did not have, and we wanted to take coffee, we did not have a plastic, single-use plastic coffee in the cup with a straw and all these things. This is amazing. I mean, and if you consider that if you're going to drink, I don't know, 3-5 coffees a day, imagine the amount of plastic that. So why not use a glass or a refilling scheme? So we have to get rid of our convenient life. This is the heart. So we need to change our mindset. And in Inspire, we are also trying to do that. But I think people of my age, it's a lost story. We need to work with the young generations because it's very difficult to deal with old guys. So we better invest in the future, which is our kids and the younger generations. There is the whole point.
Yes, correct. Thank you, George. Luckily, also in Inspire Project, we have a lot of partners who are dealing with more social science fields. And regarding the age, we are still we changed your mind, so we can do it on the others as well. So yes, maybe I think we are coming to an end of this round table. It was very interesting discussion, let's go. But maybe if we start from somewhere and then beyond, what do you think? What does the future show? And how do you see this plastic pollution and micro, especially in the future?
It's a very difficult
Correct.
question. No, I think that projects like Inspires are doing a very good job, not only in developing the technology, but also in raising awareness in young, but also in young spirit people. And it's when you do the raising awareness activity with the citizen, the good thing is that the plastic pollution is a type of pollution that you can see. Macro, the macroplastics. And this is really, really when I perform the cleanup campaign with students, they can touch the pollution on which. And so they really realize what they are collecting, so that most of the items derive from public activity. So this is really important that projects like Inspire do these activities to raising awareness, because the young people are really responsive. And so I think that we are working for something to change something, the behavior also of young people. So I'm positive because we are working, we are doing research activity to solve the problem. Then we are also doing raising awareness activities to prevent the problem. So we are conducting all the possible activities that we can do to solve really this problem.
Thank you, and also great work also to you and Santina and your team. I know that Siena is really fighting to fight against the plastics from the previous projects now and also the future. So thank you very much. Marco.
Two quick comments. ACS Promising the New European Digital Cleanup Ocean is a new initiative that try to solve the issues that the monitoring and restoration activities are not managed with a holistic approach. And this digital ocean also tackle the issue of also plastic pollution from the point from river to sea. So it's a new emerging technology where the European Commission is giving a lot of funds and a lot of investment, and I think that this tool, especially with young generations, will help us to tackle better this issue. Otherwise, I see that in the last years, the awareness of the citizens, of the young people, is much bigger in comparison to some decades before. And so, also myself, I'm a positive person, and so I see this issue that positively that will be solved in the coming period, but we don't have to remember that now the biggest issue of the poor countries, poor regions, I think to Asia, Africa or South America, where they are still very big polluters, and so we need to find a solution how to help them to reach our levels.
Thank you, Marco. Very good point. I would also say that we are seeing that the major plastic pollutions now are staying in the poorest countries, because for them it's not about sustainability, it's about survival. So until people are surviving from day to day, plastic will be here with us because there is no cheaper solution. George?
Well, I think that unfortunately we all live in this plastic era. I think we are in the top of the problem. It accumulates more and more. So unfortunately we are with an iceberg. We only see the top, and at the bottom there is a lot more. We are starting to learn, of course, what are the effects on our daily lives, on our health. unfortunately, the quantities get bigger and bigger, especially in the poor countries, as you mentioned. But I think that Europe also has a very big responsibility on that, in that all these investments in all these European projects are meaningless because of the lack of robust legislation. We do not have the legislative tools. Vanessa mentioned earlier that even in the new directives, we only are working for monitoring and not for the application of the technologies. This is a very big mistake. I'm talking now as CEO of a spin-off that is in the sector of the plastic pollution solutions, and I'm sure the colleagues, Kostya and Joy and many others that are producing these technologies will share my opinion is that we are practically in the valley of death, as we call this phase after the initial investments. And this is because we do have the technologies, we do have tested technologies, we can provide them the efficiencies of our technologies, but unfortunately, nowadays, nobody will invest to implement these technologies because of the lack of a proper and robust legislative framework. So if you talk with the public sector, everybody, yes, they agree and they give you encouraging words, but nobody puts their hand in the pocket to say, okay, let's install this solution, or let's try to see how we can help you. Nothing. This is really, I don't want to be pessimistic, but this is the cruel reality. And I hope that we will have positive effects, and I'm sure we will have positive effects in the Inspire project. But the main question is what will happen after the end of the project? After we will finalize our financial reports to the Commission, what will happen afterwards? Shall we have some legislative measures that will force the public authorities, our municipalities, our regional authorities to adapt such measures? I'm wondering really.
Yes, thank you, George. Very good point. Also, the other thing is how we're going to split the responsibility. Okay, who is going to pay for all of this? Okay, first we need a lot of money, but then who is going to share the responsibility? Is it going to be on the end users like us, or the industrial producers, or how are we gonna? Because we'll not be able to clean the whole Europe forever.
I will tell you an example. In Greece, we had the implementation of the single-use plastics and the ban of the straws, for example. And one day I was in the supermarket, and I was really very surprised to see straws again there, saying the ticket reusable. I mean, mercy, we are inventing always windows to bypass any positive legislative scheme, simply because we say that, okay, I will keep producing these single-use plastics if I will just say it is reusable. Thank you very much, but how many of us really reuse the point is, I should not be able to find it again, or I should be able to find only metal ones, or wooden ones, or whatever. So we also as consumers have a responsibility. That's why I said before that we need to change our mindset and behavior.
Thank you very much. And then please, Hannah and Aurelian, you can some last words.
Yeah, I also agree with the speaker that we're quite positive that there's so many growing awareness, and but also a lot of challenges in this plastic pollution. But as a researcher, I think there is still a lot of unanswered questions and how big is microplastic with the organisms, and also regarding the analysis, of course, would be a lot of effort to really standardize and to the methods so that we can report accurately on plastic pollution.
I think that the researchers, the
regional water operators works every day for resolve this problem. But I think that the solutions are around us in community. People must to reduce the consumption of plastic. This is the good direction. And about legislation, I think that it's important to modify this legislation in use in quotidian activity with plastic. And in the next period, I think that it will be important to have social campaign to make our citizens to realize the dangers of the effect of microplastic for human health. And this is a good way to reduce our problem.
Yes, exactly. Thank you very much, Aurelian. As you said, the responsibility is on us. But by taking the responsibility, we can also take the power back in the fighting of the plastic pollutions we as individuals. And with this, I would like to wrap up this roundtable. Thank you all, you participants, and the listeners. And I wish you have a good day. I'm Slovenian Turkish. Thank you.
So while we wait for Nithya, I think we can get started.
Yeah, I think so.
Why don't you take a seat?
Okay, thank you.
Right, to start with, I think we will request Marietka to introduce herself because.
Okay.
Yes, please.
Yes. Okay, so welcome again. My name is Marietka Lipstedt. I'm the CEO of the Wastewater and County. I'm working here for almost 30 years. I'm really happy to be here. I'm actually glad I deal with the wastewater. So it's really well.
Yes.
Yeah.
We'll come back to it because that is something. Well, I think Marietka forgot to say that she is actually CEO of one of the largest wastewater plants here in Slovenia. Fourth largest. One of the, I think, fourth largest. And what I've noticed, we are interacting with her, is that she's open to innovations. And that is very rare to get from wastewater plant CEOs. I have visited plenty of them. So she is a very special guest to have. Okay. Professor Luchka.
Okay, so my name is Luchka Kajtin-Patai. I'm Professor Emeritus from University of Ljubljana. My background is physics. I'm a professor of climatology, but my research interests are not just climate change and things like that, but also what sustainable development should be. Not what it's meant, but what it should be. How to sort of change not just technologies we talk about today, but also social approach to the problems.
Thank you very much, Professor Luchka. All the best professors should be from physics. So, because I'm also from physics. So, we will let Andrei introduce himself.
So yeah, my name is Andrei Podkoritnik. I am head of R&D in the Linka Idea. Maybe a few words about the Linka Idea. We are quite a big producer of hydrogen peroxide. So we were very glad and very pleased that Marietka contacted us, contacted our company for the need of hydrogen peroxide with disinfection in the project Inspire. So I'm first of all very glad to participate on this panel. It's really nice to be present in these really inspiring minds sitting behind this table and in the audience. So thank you very much for Anna Maria for including me in this panel.
Okay, thank you, Andrei. So last but not the least, Paolo.
Yes, Paolo. Hi, I'm Paolo Franceschetti. I'm from Veritas. Veritas is a multi-utility company in the province of that manages the province of Venice and the historical city center of Venice. We are involved in the waste management and water cycles management, and so from potable water to wastewater, and we are around 900,000 people that we serve, but also with more than 40 million of tourists during the year that are coming in our beaches and cities. So it's a big problem to manage them because are not so educated like Netherlands that we have, and so it's very hard work. I'm working in the research and development sector department in the water cycle, and I'm an environmental scientist.
Thank you very much.
I'm not a physics, I'm sorry. But I have done the PhD in physics.
Okay, so I think we have a very important task to do over the next half an hour or so. Let's delve into the EU policies and how we think that it could actually affect the wastewater management and how one can consider changing them. So I start off with Marietka. How do you think wastewater plants will be affected by the new directives? Because personally, as George was telling, I don't think it's practical.
Well, it's not practical, but for sure there is time there for new changes. So we know that in 30 years a lot of things change. So we know a lot of new things, new emerging pollutants are now being analyzed. We know that the nature is already endangered, and we have to do something. We have to upgrade our technology. Our technology actually works.
It is.
Yeah, it is.
Victorian.
Yeah, right. So we are actually willing to do something.
What do you think, Paulo? Tackling the 40 million people.
Yeah, that is a big challenge because the directive is very hard to follow. First, because they introduce a new focus on emerging pollutants, and so we have to treat with the third stage. But also, in the same time, so they are asking it to be energy neutral. That is, for me, one of the biggest problems, because if we are introducing a new technology, normally they use chemicals, but also electricity, and that will be the biggest challenge for us to find the correct way. Okay, we can save energy, we can during the process, but not enough to have and produce energy will be very difficult from that point. Also, taking out more pollutants and more so more.
So, Professor, how do you think that the climate policy would go hand in hand with all the additional burden that we are getting, not only microplastics?
The problem of European policies and directives, they are not holistic at all. They are just separately looking at climate change problems, biodiversity problems, medical problems, whatever. But actually, when it comes to the global problems like plastics, a global problem, you cannot just tackle one issue with one directive. Not to mention that in the last decade, the global awareness is falling. People are not more aware of the problems, unfortunately, because we have also switched in the political sense that it's not in the interest of more right-wing policy. That people know a lot of ecological problems. So this is what is wrong, and the synergies are missing. Because at the same time, tackling, I don't know, is the special machinery one problem like plastics, but at the same time using more energy, not less, so you just solve one problem and make other problem worse. And climate policies are actually connected to everything that we are talking about. And many directives are actually opposite one another. For instance, just one example. We want to be more efficient regarding energy, more efficient regarding materials. But for instance, in the medical operation, in hospitals, everything that is used once is thrown away. Not just, I don't know, bandages, things made from iron, the knives, the scissors, everything, because the directive says so. So it's crazy, you know, and we are actually, as a voters, the Europeans, we are not fighting against that. Lack of holistic view.
Well, what you said is totally correct, and we haven't learned. Because during the COVID, we had a lot of shortage of PPs, a lot of shortage of various filters, and I have seen them being used because as a patient, the doctors were asking me whether they could use the apparels. They were disinfected using sodium perchlorate. Now, as a scientist, I had no problem. But many of the patients in the hospital ward where I was there, they just refused.
It's a mindset.
It's the mindset. So you have touched a very nice chord there because the policies are fractured and there is no holistic policy covering all of them. And the panel before talked about changing the mindset of people. What I want to add there is possibly we don't even learn from what we had already practiced. With that, Andre, I think what is your view of going out of business? Because chemicals are a no-no for Paolo. She talks about it also that you have to be energy efficient. So hydrogen peroxide, nobody will buy. How can you survive?
Interesting question. Yeah, I'm coming from the sector that is very in the mind of majority of our community. A big problem. Practically, the plastics were developed by chemical industry, not just plastics, but all the micropollutants that are now in our water, our drinking water. That's, in my opinion, one of the biggest problems, and also in the food that we are producing. The agriculture we are tackling, and we have a lot of, we see a lot of opportunity in agriculture with hydrogen peroxide, because you were mentioning chemicals. Hydrogen peroxide is very environmentally friendly, because when it works, it decomposes into water and oxygen. So we are not forming any very bad byproducts in score when we are talking about disinfection. Maybe in other segments, when you're talking about AOPs, the AOPs process is not directly to the end. You can form some byproducts. But my opinion is that European Union's regulation in that regard is, as the professor mentioned before, not holistic. In certain areas, for instance, in the United States, in certain states they forbidden use of chloride in treating wastewater and also drinking water, because of the byproducts and the consumption of communities, which is very problematic for our health. And now they are using hydrogen peroxide. Of course, the biggest problem in the European Union is, of course, when it comes to funds, money, because hydrogen peroxide is more expensive and it's harder to produce. You need it more. So, in my opinion, we should focus using right chemicals, environmentally sustainable chemicals that do not produce byproducts, and as was mentioned before, European Union should look the system and bring this into a policy in a holistic way.
What could be your wish list from the EU REACH for, from perspective of wastewater treatment? Your wish list.
Wish list?
Yes.
From the perspective
of, tomorrow you are supplying the wastewater, you are doing wastewater for the region.
Yeah.
What would you like to do tomorrow?
So the vision of
the vision.
Yeah. So the vision for my perspective is to get the wastewater out of the treatment plant to be able to for agriculture, maybe also for some industry. Like the summer, I think it will be some usage. Then for sure that we are self-sufficient. We are already self-sufficient in energy. That we will maybe burn sludge and produce phosphor of the ash. And some other things, maybe biomethane or hydrogen, electrolysis. So there's many options actually.
Yeah. Pablo, how much percentage of the tourist tax that we give to the hotels do you get back?
Not so much. We don't get so much money from the touristic days. For example, we have something like 31 very small water treatment plants in Venice city center that they are working with membranes because they have just one or two cubic meter to work, and it's very complicated. So a lot of water, wastewater, is going right now also in the that is we have to work on that. But the investment are amazing. We are speaking about 4 billion just to create the sewage pipes, the sewage net, and to collect all the city center of Venice. The problem is that the tourism is growing, and also it's very fast tourism, and so they produce more with more waste and more wastewater. And our dream is to be able to collect the water and then move like you for agriculture, because right now great part of the new legislative Italian legislative acts that we not are able to waste the water, treated water inside the land, because there are limits that are so low that it's lower than the drinkable water. So we have to push all the water directly in the sea with enormous consumption of energy, because we send 20 kilometers outside from the coast, and with disinfection, with high standards, and we are wasting something like 40 million cubic meters just from one wastewater treatment plant. And we have to move the idea and the law, Italian law, but also European law, to use it for agriculture, because also we have the saline water, that is salty water that is entering the rivers, because we are managing the river mouths of the biggest rivers of Italy, and it is a very big problem that for us and for agriculture and so on. And so we have to reuse it. We have to find a way to reuse it. Also, to find just to close a way to reduce the water that is used from companies and agriculture, because we have done a calculation in our present project that in our area we are using something like 8% of the water that is used in general for drinking water. The average is from agriculture, especially around 90%. So we have to reduce that, because if we really use clean water, it's just like a drop in the sea. But it is a challenge that we have.
Professor Lushka, I think he has set up a perfect question for you. When I was coming from Munich to Ljubljana, the languages that I recognized were more that I could hear. So I heard people speak Spanish, French, English, Swedish, German. There were hardly a few people who were speaking foreign languages. Very few Slovenians, I could see that. So that means the tourism boom is kicking up here. How do you think that Slovenia could address the same problems that they are facing in Venice?
Yeah, over tourism is something that is a fact, and just our way of life that turns our feeling what is actually quality time, how to spend quality time, means you have to travel. So something is very wrong with our perception of this listening, but I will not enter that. It is a burden, but it's in combination. Tourism comes with it, not alone. Comes really with a combination of climate change also. I must stress that, because it's a very different story if you have normal weather and a lot of tourism, but if you have very hot weather, if you have a very dry weather, which is common now, it means much more problematic. More problems, not just with drinking water, but with pollution itself. My point is that when we talk about reusing the water, we have to be aware that different climate circumstances are arising. So all the factories or cleaning settlements should really be resilient to what is happening now. Because we can nice river over there, but this river in few months can cause massive flooding. So are these technologies ready for touch ban? Or we can then get all our these products just spread away. The other thing is dry conditions. Our summers in Michigan become really dry, so this is essential that you provide water for agriculture. It's not an option. This is something that you have to calculate into your future plans. So nothing occurs in vacuum. Everything comes at once. And again, people who are dealing in tourism, with tourism in Slovenia, they don't know much about climate change or in water or water treatment. They don't think about that. But somehow there should be sort of institutional approach that should be more also holistic inside the country. Because we have Minister for Environment, Minister for Agriculture, Minister for... And they all have this idea of growth. In tourism, we are only successful if arrivals are growing, I don't know, 10% per year. But you know, Slovenia doesn't grow. Europe doesn't grow. This planet doesn't grow. So that's again this mindset that what is really important, what we want for our children, for us in the next decades. Because for sure we cannot do business as usual. This is not an option.
Talking about tourism and the use of water, I saw an extreme case when I was living in Oman. The government invested. They were treating the water to a very good level. It was a German company doing it in Moscow. 90% of the water they were throwing back to the sea because the percent of the people worked in. So, is there any movements around? Like I know that in EU we are talking about citizen science. In Inspire we are talking about it as well. But in Slovenia, are you doing the same or just debating?
I think water is important topic in Slovenia in schools, and people do have also sort of an attitude that nature is worth something. It's not like taking for granted. But when it comes to action, when you really have to change your lifestyle, that's a different story. Then we will do it tomorrow, we will do it next summer. So this is why we need governments. They have all the tools, they have taxes, they have subsidies, they carrots on the stick to help us to decide faster. But they are not doing the job either.
How easy it is to tap to those resources as Professor Puchka is pointing at.
You mean how easy is it?
If you need cash.
Oh, to cash?
Yes.
Well, it's not easy, for sure. So we need
welcome to everybody's work.
Yeah, definitely we need our so the owners to say yes, we go for these investments. Also, if there is no legislation, so for first legislation, then the owners decide.
You know, in Sweden we had this microplastic boom. Maybe a decade back. Sweden was one of the early adapters of microplastic problem. I'm there for a decade now. We haven't yet sorted. Yes, what we do is NBR, and we get the plastics together with the sludge. In drinking water, it is there or not there, nobody tests. But anyway, all bottled water, at least in Scandinavia, has microplastics. Probably in Slovenia you don't have.
No.
But a Danish lab has checked 100 different bottles of different companies. All of them have. So microplastic is a problem that will stay with us. How can we steer through the European legislations and go beyond that? Because what is happening now in Sweden at least is that we are talking about a cocktail effect. Okay, so mixture, because plastics are very good for accumulating other contaminants. For example, you have a pharmaceutical plant.
Yeah.
The input water that you get, you have a directive for that? EU doesn't have. I'm just asking if you have in Slovenia.
Sorry, I don't understand the question. So if we
There is a company here manufacturing.
yes,
APIs, and then they are giving you the wastewater.
Correct, they are.
So the wastewater, do they give you a certain quality of wastewater that you know, or just they just
Yes,
push it?
it is legislation. So what kind of quality of wastewater they are allowed to discharge into the sewer system? So the question is if they are obeying that.
All right.
But this is the standard, CODBUD and so on.
Okay.
Not
So,
about this type of pollutants, we don't know.
so and that is a catch-22 situation because I know you have problems when it comes into your system.
Yes.
Because the drugs will behave differently with the microbes than simple, algae or fungi. So that becomes a problem, which reminds me, recently I visited one of the so-called modern wastewater plants in India. And I can tell you that at least 5 of the meters there were tampered. So that brings in, and I was visiting there with the minister. So I told the minister that India is so advanced. Why don't you make certain that the data directly goes to your ministry instead of them giving you? So, for example, the Inspire project, Marco is developing this toolkit. If you could get hold of the data, not you, you are the receiver side, but the legislators could get it. Do you think that is a way we could train them up for future legislations that they can control? Because there are some good and some bad treatment plants.
Yeah, here is a lot of challenges to do. Sure. Need some time.
You need money.
No,
Time.
just money.
He needs time.
Yeah, we do.
So with time you can buy if you have the money. So it's a vicious circle. Huh? But again, I'm taking a lot of examples of Sweden because wherever I go, they say, oh, Sweden, everything is so clean. We have a lake called Vatten. It's in Jönköping. It serves about the same number. I think you are serving Ljubljana 300,000 people. Yeah.
Is that no? No.
So anyway, that Vatten also serves about 300,000 people. And it is lake water. Only recently they found out that it has a lot of PFAS and a lot of antibiotics. So the plants are not capable of doing it. Is there any legislation that way here in Slovenia? In the EU, I don't think, George, you know better. Is there any?
No, not to my knowledge.
PFAS, are you looking at it as well?
I know in Slovenia there are some research groups trying to adapt the.
In Sweden it doesn't work because wherever there was army people, you had fire extinguishers. There is a lot of PFAS.
Yeah, we have our own fire squad in Velika Bratislava, so it's we have to replace foam systems, fire extinguisher for our own. So it's quite interesting. We are testing, we're trying to find institutes to test PFAS in this kind of chemicals. So to replace them, it's very expensive. This is a big problem for the chemical industry to replace these chemicals. So yeah, but when we are talking about legislation, we are still don't know what is going to happen with these kind of chemicals. Some of the companies we know from other parts of Europe, this is a shush kind of information, but some are dumping the chemicals into seawater full of PFAS. And it's really regard. Because the right way to dispose this kind of chemicals is really expensive. No.
PFAS has got a life of about 1,000 years. Microplastics has half the life, but still, both are equally a problem.
Not to mention the scenes from the past. I remember when DDT was forbidden in Yugoslavia and Slovenia, there were hundreds of tons of it. It disappeared overnight. Nobody knows how. Somewhere. No, or maybe somewhere in the ground. Anyway, so we don't know. And also, I also feel a bit not so optimistic regarding the number of chemicals available, officially available. I don't know if you are familiar with the number. Right now, it's 350,000 chemicals, officially. So there's not a single country, even with the money, political will, that can test the consequences, not to mention oxides, because you end up with the enormous. So this is sort of a problem that is.
You have struck a very nice note there. It's for him. REACH is very painful for a chemical industry. Sure. How are you tackling it?
Case by case, step by step. It's a really big problem. Practically all regulation. We are one of the also PPR regulation. We are part of the PPR regulation for hydrogen peroxide. We are practically only one producer in Europe who has now been approved for use of hydrogen peroxide in drinking water. So we are very proud of that. So we try to find right partner because we as a company are too small to tackle the REACH and PPR regulation. You have to have consultants from outside to bring the knowledge of the legislation to certain details to tackle this kind of legislation. But what I would like to mention is the legislation in the environmental sense in the European is very problematic because we are in a certain way pushing chemical industry to the border of the European Union. And we are not doing nothing for the environment as a whole. And that's a big problem. Just a few weeks ago, I was talking to my colleagues in Serbia from the institute, director of the institute in Serbia, Chemical Institute. He told me that practically they are now building a big company for the producer of phosphoric acid. The production would practically supply the entire Europe because in Europe there is no more no company who is producing phosphoric acid and the demand is huge. Yeah, and they are polluting there much more than here in the European Union were companies before. So this problem is really big for the European Union.
Coming back to wastewater, Malika, think about it. If we could put on a taps, all of us, we get water through pipes.
Yes.
So if we had a water meter, how much water is going in, can we think about a charge to our citizens for treating that water? Would that work, you think?
You mean the effluent? Or
No,
the
influence.
Influent, they already pay.
The influence, they pay the cost of production of water. But for the cost of treating this water, if we had another little tranche out there for the influence, because whatever is coming in has to go out.
Yes.
And what is coming in is from the water manufacturing company.
Yes.
And what is going out, you are not being paid for that. Yes, you get paid by other means, but not per liter, per cubic meter from each household. If we had,
in Italy, we have a tariff, and more or less is alpha is for drinking water, and alpha is for treating.
We have
The problem for us in Italy is that the tariff tariff has been.
I didn't know, so that's what I'm asking.
But the problem that in Italy the tariff was managed by politicals. And then they try to take vote, they give access to vote of the citizen approvals, and so the tariff was very low. We are right now around 1.5 euro per cubic meter to have drinkable water and drinkable water. And but if we compare with Denmark, they pay 12 euros per each cubic meter. And so the problem was that we were not able to have maintenance, to have investment in water treatments or supply and the net, and that is became a very big problem. Now they are trying to move, trying to step by step increasing the 4% each year to go up because the target of in Europe is to spend around 100 euro per each for each person and for as investment. Right now in Italy we are around 60 euro, and in some parts of Italy there are less than 30 euro per month per year. And we have to increase the tariff. The problem is that the political people they don't want.
They will lose the election.
Exactly. But we have the lowest, one of the lowest and cheapest tariff in Europe, but it's a big process. Because also we have to follow the directives that are asking more investments. And so
we have both of you. In Sweden, we have another crazy system. Is that if you have a cluster of 50 houses, then the wastewater is still not reached. Anything less than 50 houses, not reached.
Where does it go?
Anywhere.
Okay.
Well, yeah, septic tank. So that's basically if you have a cluster of 50. Now, I checked in the European Union, nothing was mentioned systematically. But how do you follow here? For example, there's a summer house somewhere.
Individual system needs to be done. So this is small.
Okay, is there any way to control the
Yes, sure. So you have to tell the water company that you install small wastewater treatment. Then they're checking every 3 years and monitoring the
so
first year.
I curse because in Sweden they check every 6 months, and I say that is not enough.
Yeah, I know.
Again, see how these politics are not being considered the right now. So, spatial planning is the core source of the right distribution of housing that you can do. So you are not supposed to allow to build houses wherever people want every year. So at the end, but they don't work together. It's totally different.
But don't you think there the synergistic effect of making people responsible would work together with IoT to monitor their individual? Don't you think that could work better? For example, if you have a device fit in there, like they put in US, the ban for the criminals without sending them to the jail. So probably, if worst comes to worst, we might have to think that way. Because anyway, in order to continue with the water industry, we will need investments. You're talking about Denmark. Denmark, the pipelines has been totally replaced. And that is why they are putting this high tariff. Because half of that is directly given to the pipeline treatment. So,
Europe is always talking about energy security, food security. You never talk about water security. Water is not at the same level like oil or coal. It is supposed to change because without water is not no life and no health actually.
Coming back to microplastics, how do you think that we can make it, more evident here in Slovenia. I'm focusing more on Slovenia because we have two panelists and him around. Can you think of transnational courts or transnational policies? But again, policy just if it remains a policy, then it remains a policy. So together with it, like we are doing, technology pilot that one puts in. So how could Slovenia think of, for example, now DO has given a little push to do a small little thing. Can we activate the Slovenian government to try and see that, okay, you can scale this technologies or some other technologies slightly bigger scale? How do you see that?
Well, unfortunately, Lydia is not here. She would be the one that could tell us how she's seeing the way to communicate and push this research further. But definitely, we have to communicate in different levels. We have to spread this information and analyze it to other research groups. Go on, just go on, keep on.
I think it's not the government we should focus on. We have to change the voters. The voters are the problems because if they don't see water problems as important, then they will vote for the same. And one trigger, what I don't observe when we talk about climate change, they also ignore it. And the only thing they really click is when we talk about cars. Heat waves, people die. I don't know, people die. So cancer. So unfortunately, this is one way to go to show that microplastic affects our health. That people don't care about shells, about ocean. They really care about money and their health. So unfortunately, this is a bit, how should I say, cynical, but that's a fact. So we need research in Slovenia to show how huge effect microplastic has. And of course, media to tell that once a week, and then we can change things.
And what do you think about the chemical industry's perspective?
I would say maybe first of all, I totally agree regarding that. As mentioned before, fear of the people is very effective. And maybe this kind of roundtables, this kind of discussions, the most important is to bring facts to the people so that the people will understand the problems of the bottles of every bottle of water that they buy, of every product that is packaged in certain plastics. So this is really important to emphasize to not just Slovenians but for entire Europe. So this is part of also of the researchers of the so-called institutes to bring the knowledge to the media. The media was here today in the morning. I hope that they get and we spread the message in the right way to bring this to the voters, as you said. Regarding chemical industry in the European is very, very well monitored, and even more will be monitored in the future. Here in Slovenia, we have WWTP. Now that it's very big for European, for Slovenian companies, and it's really hard in some cases for the industry, for us. But it's really different from industry to industry. Our biggest pollution for our company is CO2. We are one of the first companies that in our industry started to store. We have our own CO2 storage plant, and this is, and now we are also tackling carbon capture utilization technologies. our own developed technology in-house to tackle this kind of problem. So we have to, first of all, bring policy to the European tables that would understand, first of all, we need chemical industry so that people have jobs, so we do not pollute behind borders, and to bring all the parties to the table to discuss this policy, not just in a quick way, sign the policy and here is the tariffs, here is the taxes that you have. So this is my
last words.
Well, we just started. We have a long, long way to walk, but we will not. How to say? We will just continue.
You have to keep fighting.
Yeah, thank you.
Paolo.
I can say that first we have to find a way to change the plastic that became more biodegradable. Because if we don't start from the starting point, it will be difficult because we can divide the filter but also it's difficult to destroy it, and we are not able to manage the plastic that is spread away, especially microplastics. So we have to find a new materials that are more biodegradable. First, and second, yes, is to change the mentality of people. It's not possible that in Italy the normal consumption per each person is 450 liters per day. That is amazing. I don't understand why the Italians are using so much water. And also the plastic that the people, we are the biggest consumers of water in bottle. That is completely stupid. For example, the people in Italy, especially in Venice, are drinking one brand of water that is coming from the same well of the water that we have in our region. No? And they spend a lot of money to buy the same water thinking that it's better. So producing plastic and just the company closer to Venice that produces this water produces 6 million per day of bottles. 6 million, and just one company, the entire group. And so we have to change also the mentality at a holistic approach because that is the main issue, the main challenge.
Last words.
My dream is that in Europe at least we finally make it happen what is written in Lisbon Treaty, that polluter pays. All these companies that produce this or that, they should pay. So external expenses, this is not longer something difficult. It had to be reflected in the price of this water, the price of bad things. This can be done now. 10 years ago, the science did not advance enough, but we need to really good connection with or new generation of politics and CEOs also, because what you said was wonderful. You all do that, but your profit because of that is a little lower.
Yeah.
Because you invest in that.
Yeah.
So we need owners like that. Not maximize profit, but maximize sustainability.
Well, that's never going to happen because man is defined with greed.
Yes.
So that's never going to happen. But the only thing I'm worried about with all these policies is hopefully it doesn't drive our industries out of Europe. Like he gave already an example. But I totally agree with you regarding the fact that we are much more responsible than what we actually back. Now, probably we should start selling these concepts to the ulterior world, and then only we will get in this global trade kind of situation. Unless we get other people to also behave in our way, I don't think we will be economically viable if we are just trying to capture the carbon like he does. His H2O2 will be much more expensive than what the producers in other countries might give you. So unless we bring in that sort of parity, so back to it, the the couple has to have to come back. There's no other way. Okay? With these final words, I think let us get going. Let's hope that we will reduce a little plastic in this river, and that will let his fishes grow. Thank you very much for your attention. George, you have to tell something?
Yes, Anna Maria is giving now an interview for the TV, so she asked me to say a few words as a wrap up. We want to thank you very much, especially you, Marietta, for hosting us. Thank you very much. Thank you very much, all of you. I want to extend our great thanks and appreciation to all the people, especially Jan, that assisted us so technical staff of the Gonzalez wastewater treatment plant for their efforts to realize this installation here. And all of you, of course, for your kind participation and active involvement. Thank you very much, and I hope that all of us get clear messages and thoughts for a better future without plastics. Thank you very much.